Friends, here today we will see the depression of beam loaded at center. In previous cases, we have discussed the cantilever means that beam is fixed at one end and load is attached to the another end. Here is the case depression of a beam loaded at center. See, in laboratory work there are two experiments in concern with this elasticity which you have to study. In that first experiment with concern with this depression y, that is y by cantilever, and again in concern with the beam y by bending loaded at the center. And here is the case when there is a beam which is supported at two ends and the load is attached to the center. Then what is the depression we get? And therefore, to perform this experiment, we have to carefully learn the theory of cantilever which we have been already discussed. Now we will see y by bending loaded at the center. See now, let us suppose that this is a beam AB and it is supported by two knife edges. These are the two knife edges, and the beam is loaded at the center, middle center. C is the center and it is loaded through the weight W. Then what happens? The reaction of these knife edges, then the reaction of each knife edge will clearly shows that this W by 2, this is the upward reaction of this load. Upward direction, this force is acting. Again, we can say that the middle part of the beam is horizontal. The beam may be considered an equivalent to inverted cantilever. See now, if you can imagine that this is a one inverted cantilever, again this is another one. Means that this acts as a two inverted cantilever which are fixed at C and the loads W by 2 acting upwards at A and B. This W by 2, here this is W by 2 acting upwards fixed at this end, and therefore L be the length of beam AB, which is here AB having the length of this beam, and C, that is the length of each cantilever AC and BC, is L by 2, and the elevation of A or B above C are the same thing, the depression of C below A and B. It is given by this formula, that is depression Y is C. Now this formula we have discussed for the cantilever, and here we are considering that this bending of a beam loaded at center behaves like two inverted cantilevers, and therefore W by 2 in bracket L by 2 cube 3y AK square, and 3 here W L cube by 16, because cube of 2 is 8 and 8 multiplied by 2 is a 16, and therefore this 3y square by 1. Here by simplification w equals 16 3y square, and lastly here WL cube by 48YIZ. See now, if the beam is a circular cross section, then the depression is given by y equal to WL cube by 12y pi r raised to power 4. See, this pi r raised to power 4 means area of that circular beam. Now if the beam is of a rectangular form, then what will be the depression? If the rectangular form or cross section is taken, see, rectangular cross section having a breadth b and depth d, then the formula can be written in this way, that is the depression y equals to WL cube by 48y 12 by BD cube, and automatically this 12 uh, divided by 48, that is a 4, and y BD cube and this WL cube. In this way we will get the y depression y in the bending of a beam which is loaded at the center. Thank you very much.